Okay, in this sessions, I'm going to show you how to do the homework on the logarithms, which is at the bottom of the attachment I sent you. So first question then, we have find the value of y such that log to the base 3 y equal to -1. So I will write that down. So question 1, part A. So we have log to the base 3 y equal to -1. Okay, so what we've got here is to utilize a rule, because in lessons we kind of said log AB is equal to x, and that's the same as a to the power of x equal to b. Okay, so if you compare that, your a, which is your base, which is now going to be the integers, so 3 becomes so let me just cancel that in blue. So 3 is here, and it's the power of the x, which is this number here, and that equal to y. So y is equal to 3 to the power -1, and we know -1 meaning is to reciprocal to get us 1 over 3 to the power of 1 in positive index, and that's the same as 1 over 3. So the first answer is 1 over 3. Now for part B, we have log to the base p 8 equal to 3. So same thing, using the same rule, log AB equal to x, so a to the power of x equal to b. So we write p, which is the a, yeah. So and then is to raise it to the power of 3, and that gives us 8. So to find p, we need to do the opposite of cube, which is to cube root the number, the term, and so I must cube root 8, and just happen 8 is a cube number, so it's going to be a nice and nice number 2. 2 times 2 times 2 is 8. Yeah, so that's B. Now on to C, we have find the value of log to the base 4 8. So what's the answer? Well, first of all, it will equal to an answer. Okay, so I'll call that y, and then using the rule that we've just been doing, so it's 4 to the power of y equal to 8, and that immediately get rid of the log. So 4 to the power of what give you 8? Well, it's going to be a decimal. So, but the thing is, we want to find what y is. So we could take log to both sides, yeah. So we can log this side, and we also log this side. So then what we can do, why do we log? Because I can bring the index variable. This is called variable because it's an unknown. Then you can have it as y times log 4 equal to log 8. Now, what's the difference between this here and the one here? Because now this is base 10. Because if you remember, you might think, oh, so why can't I just put that in the calculator? Because on your calculator, the log button is to the base 10. Okay, so that's why we can't just directly put that in the calculator. So now I have taken log to the base 10 on both sides. So all this are base 10. And so I can now flip this term to the other side because it's times y. So all I have to do is to do what to both sides? I divide by log to the base 10 4. On this side, I must divide by log to the base 10 4 on this side. And so that term cancel out, giving you y is equal to that. Well, did we not learn that if you log a over log b, I think we can just put that straight into the calculator, couldn't we? So we can do that straight into the calculator, or if I just do that, get the calculators up. So y is equal to log 8 divided by log 4. So that's 3 over 2. And I remember I said that in the lesson, the answer. Or you can write 1.5. We kind of like to keep it as top heavy because normally we will continue using this number to work out something else. It wouldn't be our final answers in a problem. Okay, so I was just looking at this and thinking, well, is log a over b, can it be written as log a over b like so? So I'm going to find out now. So if my rule works, they should equal to 3 over 2 as well. So let's try that. So that equal to log 8 over 4. And that means all I have to do is put in the calculator log 2. That should give me the same answer if this rule that I'm thinking of applies. Remember, I told you I don't learn the rule. I test them out. Okay, so and it will only take you 30 seconds really. So let's see if log 2 is right. I have a feeling it's not. If it is, then my rule is valid. Nope, it doesn't work. Okay, because 3 over 2 is 1.5 and that doesn't work. So this rule doesn't work. So don't try this at all. Okay. I'm just thinking, what if I haven't got a calculator? Is it possible that I can get the answers 3 over 2? I still think you can. It's just that I'm not thinking quite clearly at the moment. So let me think about this. So let's see if it works. So I'm just got an idea. What if I can make the top part is also log 10 over log 10 4 as well? Because 8 is 8 times 2. So couldn't I just do it like this? Log 10, and then I'm just going to split that to 4 times 2 over log to the base 10 4. Now, I think we learned a rule that if you have log xy, that's equal to log x plus log y, isn't it? So that means I can split that to log 10 4 plus log 2. So I'm going to do that, and I'm going to split that into log 10 4 plus log 2 over log 10 4. So they are. So now I'm going to split the fractions. So that means is log 10 over log 10 4 and log 4 as well. And remember, top and bottom the same, is divide by itself, which is 1. And I will get log to the base 10 2 over 4. No, just make that simpler really. So it's just 1 plus log 10 2 4. Now I'm wondering that I should know that this is actually this, yeah, because 2 over 4 is a half. So that means log 10 and log 10 can be cancelled out. But if you cancel that out, 8 over 4 isn't 2. So it just happens that this answer here might look like 1.5, but you mustn't put a half. That's just a good guess there. So So I'm guessing in the end I still have to put it in the calculator. So possibly I can carry on because 4 is 2 times 2, so I can simplify again there. But yeah, it's gonna go long. So I will leave some A-level students to maybe have a look at this problem again in the future and tell me, sir, actually there is a quicker way to get that without using a calculator. I'll be very, very pleased if anyone can tell me and show me the way. Thank you very much. So that's C. So on to question 2 now. Again, there are 3 parts to that question. So this time is express. So it's asking us to express as a single logarithm to base A expressed as a single logarithm to base A. So the question is 2 log A 5. So let me see what they're asking. Use law 4 to write. Okay, and then use law 1 to combine the 2 logarithms. So, okay, well, this one is quite simple because the rule states that if there's a coefficient in front of a log, you could raise that to the power, isn't it? So therefore, it becomes that, and that's the same as log to the base A 25. Now that's what it's trying to get you to do, is to express it as a base A logarithm without any coefficient. So let me just double check the answer book. Yes, it is. So that's sorted. So that's 25 log to the base A 25. Now on to part B. We've got some adding. So we got a log to the base A2 plus log to the base A9. Because they're both base A, we can apply the law of logarithm because they're adding, which means you can combine them to be multiplying. And so therefore it's just log to the base A 18. Okay, that's your final answer there. And now lastly, part C, 3 log A 4 plus, take away log to the base A 8. So I can raise that, become a power because it's in front of a log and it's a coefficient. So that's just, if you check your notes and look at the rule again. So 4 to the power 3 minus log to the base A 8. Now 4 to the power 3 is 4 times 4 times 4, which is 64. So that comes to log base A 64, take away log base A 8. When you minus 2 log value, you can divide them. So when you add 2 log values, you have to times that term there. So divide is from the takeaway version. So I can simplify that to A 64 over 8. And how many 8 going to 64? I eat, I sit on the floor. So there are 8 lots. So that means that simplified to 64 divided by 8, which is log base A 8. Finish. Okay, just double checking. I haven't made any mistakes. Otherwise, this video will be invalid. Perfect. I've done it all correctly. So there you are. I hope this video will help you digest this and consolidate the learning. If there's any questions on this and you want me to show you again in lessons or at your spare time, please let me know via Microsoft Teams. Thank you very much.